This help video is going over the flex fuel strategy of the Syvecs range of ECUs. When you're connected to the Syvecs, you actually see on SCAL the option for flex fuel. Now, before we get into involving the strategy and how it actually works, the first thing we need to talk about is actually assigning the Syvecs flex fuel sensors which we offer. Okay, these are a 3-pin variant of sensor which come with need a 12 volt, a ground and a signal out back to the ECU. Now the signal going back out is a frequency input which is actually coming from the sensor. So basically we actually need to go over what pins and what inputs can be defined and used with what ECUs. Now with the S6GP ECU there's only 8 inputs which can actually handle a frequency type of input. These are inputs 1 to 4 and 5 to 8. These inputs are the only ones that can handle the frequency type of signal that is coming on the actual input pin. Now on the S8 you can put it on either pins 1 to 16. Okay, once those have been assigned and wired in and the pin has been put into the appropriate option based on the pinouts that are on the Syvecs forum, we need to go down to the I/O configuration on the ECU and pin assignments. In here you'll be able to scroll down and on inputs you'll find the option for fuel composition. Under fuel composition you want to basically select the input which you assign. So again on an S8 1 to 16 can be used, so we're going to put it on AN14 for this particular setup. Now as this is a blue item obviously highlighted here, the actual ECU needs to be programmed. So in order to do this, it's device program, the ECU will reset, come back online up over in the top right hand corner, and then you have the ability to see the sensor working. Now to make sure the sensor is working first thing we want to do is obviously go to sensors, go to fuel composition, flex fuel, and in here make sure the setup is correct. Now as default it will come in hopefully on the base calibration you've got as a default setup, which is obviously set as for Mr. High voltage threshold has 3.75, low voltage is 1.25, low frequency error range is 45, minimum is 0, percentage of fuel comp is 50, and maximum is 100. This is the default amount that's normally needed on the GM Syvecs sensors which we use. Okay. Now once that's all set, the best thing to do is actually make sure the sensor is working based on the ethanol content readings. You can obviously test this on a bench, but if you want to obviously test it's working on the car and see the ethanol readings you're getting, all you want to do is go gauge, add, type in fuel comp and trace, and 10 times a second. This value will then show you in a percentage the amount of ethanol content which is current in the fuel system on the car at the present time. If you're getting no reading on this, the best thing to do is go gauge, add fuel comp voltage, and actually make sure that you're seeing on a trace at about 20 Hz the frequency input coming in, which will be a square waveform, and actually see the voltage changing. Okay. Now once that's all assigned and obviously working, we need to go up to the flex fuel strategy and talk about exactly how this works. Now the help section on the Syvecs is accessed via pressing F1. When you press F1 it clearly states here that the blend maps are done between the 4 base fuel maps and 4 ignition maps. So for example, unrun mode fueling, you have 4 base ignition timing maps. What it would do is it will actually blend between 2. So if you're using a flex fuel strategy, the base injection time 1 table would say be for normal 93, 98 RON fuel. The second one would then be for your ethanol map. Say if you had an E85 map, which is the highest content you get, or ethanol 100, you'd then calibrate it on the second table here, and then the sequence for the flex fuel will blend between these 2 tables. If you obviously want to have it so you switch between different fuel maps and you want to move it to the other one on the calibration switches, then you would select the third one and it will blend between these 2 tables. Same applies for the ignition timing and for wastegate control in terms of the target maps here, 1 to 4. And the same goes for the starting for your primary and your primary preliminary fuel injection 1 and 2, it blends between those. Okay. Now when you're in flex fuel here, first of all obviously there's the enable option there, which again is blue, so it requires a program to be done in order for it to actually turn on. And then you've got the ability to set your base fuel transitions for your 2 fuel tables. So as I said, it obviously blends between base fuel map 1 and 2, Once you've got that, if you know that you've got a linear ratio between the two comps, then you can set it up here on the tables, or if it's not linear, then you can blend it accordingly to the measurement of fuel composition which you've got. Once you've got that set, obviously the same applies to the ignition maps, the preliminary fuel starting map, the cranking fuel map, the cranking ignition map, and your wastegate target map. These are the 6 things that we find are really needed to make the flex fuel strategy work as best as possible. Now please be aware, obviously you can actually change your manifold pressure limiter base based on the calibration switch. So say if you are using a different blend of F&O and you want to run a higher higher boost maps than that, obviously you can set different boost cut maps as well on the calibration switches, which will take into account of that. Okay, so just to make that clear, obviously if you've got base map, fuel map selected 1 in here, then it will blend between 1 and 2. If this was 3, then the flex fuel would blend between 3 and 4. Okay, just come back down to here. Okay, well hopefully that covers every aspect of the flex fuel strategy. If there are any more questions, then please get involved with the tech team at Syvecs Europe or Syvecs US. Thank you.